Good morning, party people. So, how's it going this morning? I am coming to you live from San Diego, California. I love Sir Winnie. This is the only reason that I'd get out of bed before 9 a.m. on Saturday. That's excellent. So, welcome everyone to our morning stream for How to Think Like the Engine. It's good to see the regulars inside here. I see Malik inside here, Eamon's inside here, Trevor, good to see you in here as well. Hanny, good to see you as well too. Says good morning. All kinds of folks piling in here too. This is, I think, the first time that I've ever done this session live streamed on a Twitch, Mixer, Facebook, and YouTube all at the same time. And it's kind of cool that it shows your comments up there live too from everybody, regardless of where they're coming from. So like we've got folks, Louisiana, good morning. I tell you what, Louisiana, I miss Cajun food so bad. I lived in Houston, Texas for several years, and dang, I miss Houston, Texas. Ooh. Oh, thanks. You like my relaxed and humoristic approach to teaching. Humoristic, I like that. And a big thumbs up for the equipment you're using. Oh man, it's so much fun. I'm having so much fun playing around with all the gears. This is also one of the first times where I'm using automatic light switching too as well. Like this light up here isn't turned on right now with this camera angle, but as soon as I touch a button and I switch over to another camera angle, that camera will turn, or that light will turn on too as well. So it just makes it a little easier for me to get the lights and ambiance just right. I still got to get the light right for camera 2, the one that's facing you. I have a brand new light, but the tripod is too short. So when I position it towards me, it's very Blair Witchy, and I got to work on the color tinting and all that. So it's where, hello, I am coming to you from the depths of the database crypts, you know, so it's a little weird how that one works. So always a thing that I get to keep working on. I kind of water, it'll grow. That's a good way of saying it. The other thing that I like with that too is just I love improving both things. I love improving the material that I teach and the way that I teach it to kind of bring y'all new ways of seeing this stuff, you know, getting the experiences of it and all that. So this morning I'm going to talk through how to think like the SQL Server engine, which is a classic course where I really give you the foundations of how SQL Server works. It's useful for developers, database administrators, systems administrators, and this is going to be totally 100% interactive. I'm going to be doing demos continuously. There are no slides. I'm just opening up SSMS and just dumping stuff in like crazy. So feel free to ask whatever questions that you want along the way, and I'll steer off and do different demos. In all, the whole entire course takes about 3 hours, you know, depending on the level of interactivity. But my coffee shop downstairs in the building opens at 8 a.m. So you're going to get about 2 good hours out of me before I get distracted and I want to go downstairs. Currently fishing. How amazing is that? Oh, that's kind of awesome. I'm going to guess that you're looking on your phone. Richie says SSMS is of the devil or the devil itself, depending too sometimes. All right, so let's go ahead and get started. I'll switch over here to my SQL Server Management Studio. And now what I'm going to be using inside here is the Stack Overflow database. Stack Overflow or open sources everything that they do under Creative Commons licensing so that you can go use this database and run queries against it. It's very large. You like the transition. That's brand new too. I should show you that again just so that you can see it. This is brand new. And then as it switchbacks over there, so I've got a whole new theme coming with the company logo, company colors, and all that. And that was the first thing that they dropped. And I'm like, oh, I just love it. It's so cute. So everything that Stack Overflow does, they totally open source so that you can then go use it for demos. I find this so much more interesting than other databases out there. And the only table that I'm going to be using inside here today for these demos is Southern Germany. That's, you imply like an American, like you know that I'm an American. I don't know. I know where South is, but like what's in Southern Germany? Give me the city that you're in Southern Germany, and then I'll go, because I'm always curious as to which one it is. Eamon says also likes the comments up above your head. I'm trying to figure out whether I like them above my head or whether I like them off to the side. I'm not quite sure how I feel about those yet. Wiensberg, Baden-Württemberg. Yeah, no, I don't quite know where that one is. You got me on that one. Oh, Waco, Texas. Good to see you. It's probably nice weather down there too today. So the only table that I'm going to be using inside the demos today is just the users table. And the users table holds exactly what you think it holds, a list of everyone who's ever logged into Stack Overflow, asked a question, posted an answer, and so forth. Croatia, I keep hearing that Croatia is one of the most beautiful places that I haven't been to, like Croatia. There's several places over in that part of the world that I keep seeing Instagram people go over to, and it looks just absolutely gorgeous. So I'm always like, I should check that out at some point. Sweden, and of course your name, Frozen Sweden. Sweden is, I love Sweden. I was supposed to get over there a couple of times this year for Oslo and Gothenburg for SQL Saturdays, but of course we'll see how that actually pans out. Turkey, Boston, Massachusetts. I eat turkey. I eat a lot of turkey. It's pretty good. That's not true. We only really eat turkey twice a year in the United States. It's like Thanksgiving and Christmas, and that's really about it, but it tastes really good, and I always wish that I ate it more often. Dang, y'all are just all popping up with geography. All right, so let's just keep watching geography and see where y'all are from. So let's see, Delray Beach, Romania, Gloucestershire. I assume, Rich, that's how you pronounce that, Gloucestershire. I'm never good with my pronunciations. Vietnam, Nepal. Now y'all are just making places up, right? Oh, I'm on the South Pole. You're just making these things up. It would be cool if you're actually in, y'all are in Vietnam and Nepal as well. Sheffield, United Kingdom. Yeah, those are all awesome places. So many places. Rebecca, it's probably right outside here somewhere. She says San Diego, California. My San Diego webcam, I'm actually in downtown San Diego. So out here, I'm looking out at the kind of the suburbs are out in that direction. The ocean is right behind me, but it's just that I can't see the ocean from here because my office has a wall here. I would have to pick up that camera and take you out to the living room, and I'm not about to do that right now. So back we go over to here. Iceland, Havidaguldur. Oh man, I really miss Iceland a lot. Erica and I still debate all the time about whether we should have just stayed in Iceland during this whole COVID-19 thing. Russia, all over the place. All right, well, we'll go ahead and get started. So in the Stack Overflow users table, it holds exactly what you think it holds, a list of everyone who's ever logged into Stack Overflow, posted a question, left an answer, whatever. In the users table, there's an ID column. Everyone gets an ID. It's an identity column, starts at 1 and goes up to a bajillion. There's a backloaded special user with an ID of -1 for the community, but generally you think of this as a number that starts at 1 and goes up to a bajillion. That clustered index, the primary key, happens to be a clustered primary key, is on the ID column. So you think of the clustered index as really the data itself or the table itself. You usually, not always, but usually want to declare a clustering key in SQL Server, a clustered primary key that defines how the data itself is sorted. Everything in SQL Server is basically stored in 8K pages, and you can think of them as just like pages of a spreadsheet. You can even download these pages. I've given you sample ones of these at brentozar.com/go/engine. And I'll go ahead and paste that in over into the chat just so that y'all have it if you want to go download that, the same 8K pages that I'm dealing with. So everything in SQL Server is organized in these 8K pages. Now things get a little different when we start thinking about Hekaton or in-memory OLTP or column store indexes. We'll set that aside and we'll just focus on traditional indexes for now. I want you to think of them as literal pieces of paper as if they were printed out from a spreadsheet that have exactly the same data that you're seeing on the screen here when I do select star. And you can even see them if you start going into like system objects. If you say set statistics IO on, if you say set statistics IO on, it's a totally safe command. It only affects your own session. You can do this in production, doesn't break anything. All it does when you turn this option on is that when you run queries, when the query finishes, over in the Messages tab, there's going to be a count of the number of pages that you read. When you're trying to do query performance tuning, there are a couple of ways that you can improve performance. These aren't the only two, but they're just the most common two. You can read less data, or you can do less work on that data. Shooting shark revolution. Thank you. I appreciate it. So you can, if you want to read less data, the way that you measure that is you turn set statistics IO on and you count the number of pages that you're reading every time that you run a query. I am using the smallest version of the Stack Overflow database, and users is the smallest table in that copy of the database. So this is his royal freshness, that's excellent. So really, this is a really tiny object, way less than a gigabyte, but 7,000 pages is still a lot for human beings. For people like you and me, that's a really big deal. So as we're executing queries together, when I ask you to go build an execution plan, I want you to think of it as having 7,000 pieces of paper that you've got to sift through in order to execute. So what we're going to do is I'm going to run queries, and I'm going to have you tell me what you would do if you had 7,000 pieces of paper stacked up in an office supply closet somewhere with all this data. Let's go find out. So I'll start by saying, go get me the ID from all of the users from DBO Users where last access date is greater than 2014-07-01. Now, last access date holds exactly what you think it holds. The last time that person either logged into Stack Overflow, left a question, posted an answer. Jack says, I would have burned the paper, to be honest with you. Sounds like you're a developer then. This is why I don't have friends. Me as a database administrator, I prefer to put people with machine guns at the door to make sure that no one goes in and touches the paper, especially since it usually has private, personally identifiable data inside there. Jack says you're right about what me interpreting that he's a developer. So how do I execute this query? Speaking of people with machine guns at the door, how do I execute this query if I have 7,400 pieces of paper? If I have 7,400 pieces of paper, and as a reminder, here's what they look like. I'm going to say select star from DBO Users. If I look at the pieces of paper and I try to figure out, well, it's not sorted by last access date. Last access date is on here, but if I wanted to go find all the users whose last access date is greater than a certain date, I'm going to be scanning through this stuff. I'm going to be just ripping through these pieces of paper one after another. I'm going to have to go to the office supply closet and just start reading through these continuously, finding the ones that match. Well, let's go see how SQL Server does it. I'm going to highlight the query and I'm going to run that. And you'll notice that I've turned on my actual execution plan. Jedi Mind Gorilla says, okay, this was the piece I was missing in the execution plan understanding. That's the only one you were missing? The only one, Jedi Mind Gorilla. I think there might be a few more. There are lots that I'm still missing. There's so much that I learn as I go through, especially every time they freaking change SQL Server Management Studio. Good Lord. They seem to change things in Management Studio, which is kind of a blessing and a curse. I love that they're changing things, but of course the dark side is that they keep changing things and changing my demos. So in here, I've said, go find me all the users where last access date is greater than 2014-07-01. Here's my execution plan. Now, the way that you read execution plans is you read them from right to left. This isn't the only way you can read plans. You can also read them left to right, and sometimes I have to, depending on the problem that I'm solving. But when you're just getting started, the thing you want to start with is the piece from the right and push across to the piece on the left. So the first, there goes my hand. So the first thing that SQL Server did was it scanned the entire clustered index. And if I hover my mouse over here, look at number of rows read. There are about 300,000 users in this copy of the Stack Overflow database. It's a small early copy. So SQL Server had to read all 300,000 rows in order to find the ones that match. SQL Server scanned the whole entire clustered index. It went over to the office supply closet and started ripping through these 7,400 pieces of paper. Another way you can prove that it read the entire table is if I go over to the Messages tab, see it shows here, I logically read 7,405 pieces of paper. That's the whole table. That's the number that we saw from earlier. So we have more further proof that SQL Server actually scanned the whole entire thing. Now I'm going to do it a different way. I'm going to take two queries. I'm going to say select ID from DBO users, and then I'm going to have the where clause. So I'm going to do one with a where clause and one without the where clause, just to compare between these two. I'm going to highlight both of them and execute them both at once, and switch over to the execution plans. And they're the same. Techno Viking says, hi, Brent Ozar. Hi, Techno Viking. I wonder why it's Viking. That's kind of interesting. I would assume Viking, or like it's a Viking, but it's with a W, so Viking, whatever. So these are the same query plan. It's the exact same work. Whether I have a where clause or not, it's really essentially types with a list. Techno Viking. So I immediately want to go into I have so many voices. I'm not going to do the Lisp voice yet this morning. Oh, in Eastern Europe, we use the W. I love it. Oh, it is Techno Viking then. Oh, that's very cool. What do you do for Volkswagen? That's kind of weird. I wonder how is it WW over there? Or do you even say it Volkswagen? I'm a car person, so I'm always totally interested in how that whole thing works. So I've got these two queries, one with a where clause and one without a where clause, and they're the exact same amount of work. And if I go in and look at the Messages tab, they both scan the same number of pages. You and I might think that one of these is more work than the other, like returning a whole lot more rows as opposed to returning only some of them. Howdy. But the thing is, at the end of the day, if you have to go into the supply closet and read thousands of pieces of paper, this query sucks either way. It doesn't matter whether you have the where clause or not. This is your first indication when we're doing query tuning. I want to read as little data as practical. I don't want to read extra rows, extra pages if I don't have to. But when all you have is the clustered index on a table, you're probably going to be scanning this thing over and over again. If you want it to go faster, you need some kind of alternative way of storing the data to make it go faster. That's what we would call a non-clustered index. Now you might be looking at this query plan and going, wait a minute, this is kind of stupid. Why isn't SQL Server recommending an index here? Because often you've seen Clippy. Clippy is what I call the missing index recommendations. You remember Clippy from Microsoft Word. Microsoft Word had this little dancing paperclip that would pop up and go, hey buddy, looks like you're trying to write a resume. Maybe I could help. And when you weren't really trying to write a resume, you were writing a shopping list. Well, he got fired from the Microsoft Word team, and so now he works in the SQL Server team. Hey, buddy, looks like you're trying to query by last access date. Maybe you could use an index. And Clippy, well, it's a little early here in San Diego. Maybe Clippy hasn't woken up yet. The problem here, the reason why we're not getting a missing index recommendation, let's see if any of y'all know. Why didn't I get a missing index recommendation here for this query? And while you type that in over in the chat, Jedi Mind Gorilla says, dumb question number one, why was the one without the where clause reading twice the rows? What you're referring to is these tooltips here, and those tooltips are not how many rows were read, they're how many rows came out. So in here, when I didn't have a where clause, it read 299,000 rows. To get out of the way here, it read 299,000 rows, and it actually produced 299,000 rows. The one with the where clause also read 299,000 rows. So they read the exact same number. But I like where you're going. Those tooltips aren't easy to understand. Now, in the answers to the question, so why didn't I get a missing index recommendation here? Gene01 says it's because the data set was too small and it returned quickly enough. You're close. You're really close. I would give you like half credit for that one. You're pretty close. Rich Davies nails it. Rich says it was a trivial plan. So Rich, yes. For the rest of you, what does a trivial plan mean? Well, if I hover my mouse over this, See how it says, and I'll move it over closer so that I can kind of wave at it here. If I hover my mouse over this, it says estimated subtree cost. Estimated subtree cost was just 5.79 something. We call these query bucks. It's a term that was originally coined by Kendra Little, a Microsoft certified master who works for Redgate Software over in the UK. A long time ago, in a galaxy far, far away, this meant the number of seconds that it would take for a query to return on one guy's machine at Microsoft. He had a Dell desktop, and he was working on building the SQL Server engine, and he did calculations to come up with, if a query takes about 5 seconds to run, I'm going to give it an estimated subtree cost of, say, 5. These days, it doesn't have anything to do with time. It's just a general measure of CPU and I/O work required to perform a query. And if you want to get a little bit more fine-grained and detailed, you can hover your mouse over the individual operators in a plan, and you can see things like the estimated CPU cost and the estimated I/O cost. And SQL Server adds these together. SQL Server doesn't really know how fast your CPU cores are. Doesn't really know how fast your storage is. Makes some kind of oddball guesses about your RAM. These costs are really kind of meaningless today relative to how your hardware works. But knowing that these costs are there starts to explain why SQL Server does some of the behaviors that it does. So a query has to be a certain level of complexity, not just in cost, but also in complexity, before SQL Server puts additional work into building the query plan. This query was what SQL Server calls trivially simple. So see how it says up there, optimization level trivial, and there are things that SQL Server won't do for a trivially simple plan. Now, Gene asks, can you adjust the cost that SQL Server uses for a trivial plan? Yes, and there are a few different ways to do it. One way that I could do it is I can change SQL Server's cost threshold for parallelism. If I go up to the SQL Server and I right-click on it and I go into Properties and then go into Advanced, right now, my SQL Server's cost threshold for parallelism is probably something similar to what a lot of y'all use. You may have read a lot of best practices guidelines out there that say SQL Server, and mine included, that say that you should change SQL Server's cost threshold for parallelism to a higher number. By default, this number is just 5, not 50, but 5. And what that means is that for 5, if the query cost 5 query bucks or higher, SQL Server would consider parallelizing it. Now, in terms of is this relevant to Azure SQL DB, I'm only going to talk about SQL Server in this session. Just because I have to limit how much time I go into different things. This is like the opening ceremony for all of my training. And I'm going to give you a next step. After this class, the next step that you're going to go into is fundamentals of index tuning, where I go into even more details about how a lot of this kind of stuff works. And at the end of the webcast, I'll give you a coupon so you can get fundamentals of index tuning for less than $5, just so that you can go on and further your learning this afternoon. So this cost threshold for parallelism, the default is just 5 query bucks. So what I had done is I'd raised it up to 50, which people normally do because you don't usually want tiny queries going parallel. I know reading 7,000 pages from the supply closet sounds like a lot of work, but this query is super simple. It doesn't really make sense to parallelize it. But just to show you the kinds of things that wake up Clippy, I'm going to go back to the defaults of a cost threshold for parallelism of just 5 query bucks. Say OK. And then I'm going to go see what happens with my query. So let's go run the query with the where clause again. Move it around so that we can see it. So here's the query with the where clause. And now if I go into the execution plan, there are 2 really big differences. Martin asks a good question. So does that mean a parallel query is never trivial? Correct. If you see a query that's parallel, that means it went beyond the trivial phase. It went into full optimization. So now all of a sudden, SQL Server says, whoa, oh, this query costs more than... I always use a guy's voice for SQL Server because he's dumb and stubborn and he refuses to ask for directions. He's all, trust me, I got this, when he doesn't really got this. SQL Server looks at this and he goes, oh, this costs more than 5 query bucks. I should probably bring the whole team in. And so then all of a sudden, you resemble that remark, all of a sudden SQL Server brings a whole bunch of people into the supply closet in order to read those 7,000 pages. He goes parallel. The query has a parallelism icon, and then anything with what Eric Darling calls these little racing stripes up in the plan icon. So if it has Eric Darling's racing stripes on there, that means that this operator went parallel. SQL Server broke up the work across multiple CPU cores. And if you want to learn more about parallelism, then welcome to the cloud, .NET Ed. You can go into that operator and then look at the I/O statistics for each of the threads. Here, SQL Server broke the work up across 4 threads, and each thread was assigned a number of pages. They're not all even. Just like if you were going to drag a bunch of people out into a supply closet, you're not really going to perfectly distribute the work. You're just going to grab combinations of pages and throw it at people and say, here, go get started and get to work. It's a great question. When an operator goes parallel, does it always use all the cores? No, you can configure how many cores it uses, and I don't go into that inside this class. I go into it in my mastering server tuning class, but it's such an interesting thing. Not only does it not necessarily use all the cores, but it can even use cores repeatedly. Like if you write a complex enough query, SQL Server will break up different parts of it parallel and do them at the same time. So some of you who played around with max.dop 4, you might think that if you search, just to say, if you set your max.dop to 4, you might think it's only going to do 4 things at one time. It'll actually do a whole lot more than that. As the big complex queries, things go parallel at the same time. So back over here to our query, SQL Server assembled a bunch of people, took them all into the supply closet and said, let's go, broke up this work across multiple threads. Plus, up here we have, Clippy ate my hand. Up here we have Clippy up at the top going, hey buddy, looks like you're querying by last access date. You know what would help is an index on last access date. All this stuff happened because this query, if I go over to select and I look at the optimization level, all this happened because this query all of a sudden went past the trivial stage and now it got full optimization. Let's talk about, Sukir says, the Clippy voice is the best. Thank you. Let's talk about what full optimization means here for a second and what it doesn't mean. So what full optimization means and doesn't mean is that I don't want you to think that SQL Server went all the way to the end of its journey. It's not that, what do you mean the chat is ready to display messages? That's a weird thing to say. It's not that it went all the way to the end of its journey and did every possible thing in order to optimize the query. You're only ever going to see 2 things inside that optimization level. You're either going to say trivial or you're going to see full and nothing else in between. That's kind of tricky because the full makes it sound like SQL Server did everything it possibly could. Building an execution plan is just like a choose your own adventure book. SQL Server opened the book, but it doesn't mean it went all the way through every possible thing that it could do, like evaluating indexed views or evaluating column store indexes. There's all kinds of other tricky things that it can do. When you see full, it just means that SQL Server opened the book and did a little bit more extra work. Now for the rest of the class, I'm not going to talk about the differences between trivial and full evaluations. I do go into that in my class, Fundamentals of Query Tuning. So we start talking about what choices we can make in our queries to make it more likely that we'll get a good execution plan. But now, back over here to our main event. So in here, I've now broken this up across multiple cores, and if you look at the number of logical reads that we did, it's a little bit higher than last time. Before, when the query wasn't going parallel, we read about 7,400 pages. Now we've read about 7,800 pages. Don't read too much into that. Parallelism does add some extra overhead. That's why SQL Server doesn't throw it in by default in really tiny queries. It only puts them in larger queries. There is an overhead to that, but it would be more effective if my query would take a long time to execute if I broke that up across multiple workers. All right. So now when I look at this, when how long the query took to run, I'm going to be pretty happy with this though. I'm not going to be upset. People aren't going to come to me complaining because this query is running less than a second. We're off to the races. But let's make the query a little bit harder. Let's say order by last access date. I want to see the 150,000 rows, and I want them ordered by last access date. Now, you, as a human being, how are you going to execute this query when you have 7,400 pieces of paper, they're not ordered by last access date, and you have multiple rows on each page that have different last access dates? Let's go back in and take a look at the contents of the table just so that you can see what I mean. I'm going to say select top 100 star from DBO users just so that I can throw some users up on the screen and you can glance down at that last access date. You can see that some of them make the cut and some of them don't, and they're not sorted in order. And when you and your friends go into the supply closet, you can't edit these pages. People often think they're like, well, I'm going to sort these pages out into order. No, you can't, because there are multiple rows on each page that match, and you're going to have to sort them in a more fine-grained way, and you're not allowed to tear these apart. Other people are trying to access these pages at the same time, and SQL Server is trying to get you in and out as quickly as it practically can. So how are we going to do this? I'll give you a moment to think about how we're going to execute this as I take a sip of my tasty beverage. So what I'm going to have to do is I'm going to have to go get a piece of scratch paper. I'm going to have to get, as long as we're going into the office supply closet, I might as well steal stuff. So let's go rip off some company post-it notes. So when we go with our friends into the supply closet, when we go take a team of people into the supply closet, we're going to say, you go tackle those 1,000 pages over there. You go tackle these 1,000 pages. And I want you to read through here and find the people who match that last access date greater than 2014-07-01 and write stuff down. Now, what are we going to write down? If I need to go get all of the IDs and I need to sort them by last access date, what am I going to write down on my little piece of paper? Jedi Mind Gorilla says, would you also sort it by the ID and add it to the first choice? I wish that I could tell users how to write their queries. I wish I could tell them, hey, I would like you to order it by ID or whatever, just to make my life easier. And unfortunately, users don't seem to react well to that. I'm like, hey, users, could you just do me a favor and change your query to make it match the database? And they tend to give me a finger, and they're never using this one. They're never going, Brent, you're number one. Taja Reb says, is this what TempDB writes are for? You're coming into something interesting here. So what SQL Server does, when I go execute this query, let's go look at it and look at the execution plan. Yeah, Brent, you're number middle. That's exactly what they say to me. Now our execution plan has multiple operators in it. I want you to think of every one of these operators as like a standalone microservice. It's a microservice that's completely independent. It has its own surface area, its own input parameters and output parameters. So the first microservice that runs is that SQL Server is going to scan the clustered index. This is the only copy of the table that we have. So in this little microservice here, SQL Server says, I believe about 149,000 rows are going to come out. And he's right. His statistics are pretty good here. He understands exactly how many rows are going to come out. If I hover my mouse over this operator, hi Mohammed, down at the bottom, there's an output list. And the output list says, here's what this microservice produces. The arrow coming out of this microservice is just a yelled list of 150,000 last access dates and IDs. So I can see in there, the predicate is the stuff that I was looking for. Now, Frozen Swede says, after looking at a bunch of your sessions now during quarantine, yay, I've gotten the impression that order by is something to be avoided unless you want to get publicly flogged. Yeah, but you know what? Again, users do all kinds of things that I'm unhappy with. And so what I want to show you is why it's a bad idea to do in the database if you have a choice between doing it or not. So in here, this microservice produces 150,000 IDs and last access dates. So if I hover my mouse over this arrow, that's exactly what this arrow is. It's 148,000 last access dates and IDs passed on to the next microservice. And the next microservice is going to write those down and sort them. If you see down here at the bottom, it says order by last access date ascending. So that's what this little microservice is doing. And in order for this to work, this microservice had to allocate memory. When queries work, they use 8K pages just like data pages. Now, I like to use Post-it notes during my explanation because it feels like that's more intuitive. But really, under the scenes, what it's doing is it's just granting 8K pages out of your RAM in order to execute the query. And you can see how many pages they are. If you go into the Selects properties, I can see up here memory grant info. Before SQL Server starts a query, he has to come up with how many 8K pages he thinks he's going to need to do this. And SQL Server says, well, based on my data, I think I'm going to need about 13 megabytes worth of RAM. These numbers are shown in kilobytes, and I just, it's too hard for Microsoft to put commas or decimal separators inside there, so I just have to, some kind of frozen caveman, I have to tell you what they mean. 13 megabytes worth of RAM in order to run. SQL Server caches a few different things. It caches query or caches data pages. It also needs memory in order to do your query workspace. It didn't need RAM before for this query because we didn't need to write anything down, but now we do. So SQL Server then goes and sorts all of that data, and then coming back out of here, then there's this parallelism icon, which is a little bit confusing, but let me tell you how this really works. Everything from the parallelism icon downstream. And Sabi asks, can the sort even be run in parallel? That's a great question. That's exact. And I know, look, I say it's a great question a lot. I really do think they're great questions. I get absurdly excited when I get to share this stuff with y'all because when you ask a question, I'm like, hot damn, that's the same question that I asked when I was getting started. So I'm not being patronizing. These are actually good questions. Trust me, when you ask a dumb question, I'll be the first one to tell you. Those of you who've seen my webcast will know I don't play around. So back to this parallelism icon, this is really cool. What's really happening is that everything, Jedi Mind Gorilla says, I will get told, everything downstream of the parallelism icon got parallelized. Here's how it worked. You know how I said that there are 7,400 pages over there in the supply closet? In real life, you know what you would do? Is you would send your friends into the supply closet. You would tell them, go scan these, looking for all of the people over July 1st of 2014, write them down and sort them. You want them to do that work of sorting. TajaReb, I'll get to that question in a second. That's a wonderful question, and I don't usually go into that in here, but it's magical, and I'm going to do it just because you asked and because I've seen you inside here before. And Martin's right, it's just that it gets a little bit more complicated than that, which is kind of funny. So what you would have your friends do is you would tell your friends, hey, also take some blank pages inside there and go sort while you're at it. Because I don't want to have just one person do the sort. I want to have all of you break up and sort your own results. Hi, Shashikant. Now, then, when your friends came out, here's what you would do. You would gather them around like a conference room table and you'd say, okay, everyone tell me the first date that you have. And they would all kind of hold their cards as if they're poker players and they would tell you. And you would have them read out their data in order, and you would correlate the discussion so that all the data flows out in order. You don't need to resort them again, but you do need to coordinate all their yelling so that everybody gets the data out in order. I adore these little icons on the execution plans because they show you exactly what the SQL Server's doing. Howdy, Angela. which always makes me think of a favorite character from a TV show, Angela, but that's okay. So see how the parallelism icon is like multiple things gathering together in a stream? That's exactly what's happening here. The sort got parallelized, and then there's some overhead in recombining everyone's outputs into one stream in order to send it out the door, out to the select icon. Now we still had to read all of the pages in the table. So we still see around about 7,000, 8,000 reads. But this query got a hell of a lot more expensive. And to show you how much more expensive it got, I'm going to go run the two queries back to back. I'm going to take the select without the order by and then one with the order by so you can see the two. The top query does not have an order by. Let's move this around a little bit so that we can get it all on the screen a little bit easier. So the top query does not have an order by, the bottom one does. So the top query has no sort, the bottom one does have a sort. But what's different between these in terms of how hard they were? Well, if I hover my mouse over the select, remember how the query cost for the first one we said was about 5 query bucks and 87 query cents? Well, the cost on the bottom one is a little bit higher. The cost on the bottom one is almost more than twice as high. The bottom one cost 12 query bucks and 59 query cents. More than twice as much, all because of this little guy right here, all because of that sort. If I hover my mouse over there, you can see where this cost is coming from. See how it says estimated CPU cost 5.89 query bucks? That's where that extra cost came from. You can go, if you want to go through query plans and compare the differences between them to see where the extra query bucks came from. But I need to stop for a second and say, that estimated subtree cost and all the costs that I'm telling you right now, and I'm actually going to change cameras here for a second. That cost number, holy cow, it's dark out there. I can fix that, or that balance is dark. Oh, I can do that. I can do the Blair Witch thing again. There we go. No, I can fix better than that. Hold on a second here. I'm going to change the balance on my webcam just so that I can get a better color display off of here, because I don't want y'all... Oh, for some reason it doesn't think. Okay, all right. Oh, no, I will. Damn it. Please talk amongst yourselves for a second.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
There we go. All right, and now that completely screwed up my entire just chatting camera. Okay, that's great. That didn't work worth a damn. Come back over here, buddy. I want you, reset transformation, come back out to max. That's tiny. Come on, make me nice and big. There we go. Up, that's much better. The resolution's kind of crappy though. Let's fix that and move you over here. And Richie's in here going, damn it, Brent, why can't you do one thing right before the webcast? Well, so this is one of let's move you around. And y'all are probably getting seasick watching all this happen live on my stream. Welcome to live streaming. Oh, shoot. Oh, man. Hold on a second here. Let's get this just right, because we're going to be in here all morning. Might as well make it look fantastic. Jedi says, seriously, like his equipment, talking about the web equipment. Don't get excited. There we go. All right, perfect. So now I can move this thing over in the other direction again. So now, I said I wanted to talk about query cost for a second. Whenever you see anything cost related on execution plans, it's all estimates. It's all estimates from before the query started, and they're garbage. They're meaningless numbers. You will, from time to time, just as he says the latest donation box is still empty. Yeah, I got a few other things that I got to play around with inside there. And honestly, I don't want y'all donating to me. Like, if you're going to pay me something, I want you to get something out of it. Like, I'd rather you buy my training classes so that you actually get something out. And that's why I give coupons to folks who follow my live streams on Twitch, Facebook, YouTube, and all that. I give you a coupon during today. So those costs, anytime you see them, are absolutely garbage. From time to time, you'll see people like me use them for comparison purposes, but all we're trying to do is really just show you that one is more expensive than the other. We're not trying to show you that this is how you should tune queries, because they're just garbage numbers. If SQL Server's estimates were right, often it would come to a different conclusion. But usually when people bring you queries to tune, it's because the estimates were incorrect. And we talk more about that in fundamentals of query tuning. I just want to make sure that everybody gets that even though I'm using these costs here to display something quickly, it's not necessarily an accurate number to go run with. Jedi Mind Gorilla says, dumb question, while you say that they're garbage, if a server is busy, can SQL Server over-allocate too much and affect the performance? Yes, absolutely. SQL Server will make bad decisions, and it'll go both ways. It'll also sometimes undercut costs for a query that's massively, really expensive, and it doesn't go back and revisit these. Whatever it comes up with as an execution plan, that's what it rolls with for life, which is, I always find really intriguing. So if I'm going to compare these two, the top one's estimated subtree cost was, hover my mouse back over there, and Jedi Mind Girl says we need an AI aspect. Microsoft is working on that, and they've done white papers on it. But the problem is, of course, if they go back and revisit query plans, they need CPU to do it. It's going to take work and time. Martin says, doesn't go back. What about intelligent query processing? Oh, I teach you in Mastering Query Tuning just how unintelligent that really is. How it seems like it's awesome, but then when you go to use it in real life, you're like, wait a minute. This is made of string beans. This is an intelligent query. And I don't mean to denigrate the work of Microsoft. Those people are brilliant. It's just that the marketing people get involved and they call it something that it's not, like automatic tuning is the furthest thing from automatic tuning that I've ever seen in my life. It's like the opposite of that. So the top query, it's like 5.8 query bucks. Bottom query, it's like 12 query bucks. So you could do this with different, and VTOL Freak, I saw that white paper recently from the TIDB folks about trying alternative plans during idle time, and I adore that so much. I wanted to have that in the weekly links this week, and I don't think it quite made the cut. I had so many interesting things this week, but that is, I saw that too, and I was so happy with that. Sabi says, one would think that SQL Server could sort the results faster than some random developer. Yes, but SQL Server Enterprise Edition is $7,000 US per CPU core. $7,000 US per CPU core. In order to license my iPad would cost $56,000. Can my iPad sort data as quickly as SQL Server? No, but for $56,000, I can buy a whole lot of iPads. That's why we tell people to avoid sorting in the SQL Server if you can. You can do it in the beginning before you have to worry about licensing, but as that thing scales, holy moly. Sir Winnie says, at least we're not an Oracle shop. Yeah, because Oracle Enterprise Edition is $47,000 per CPU core. So to license my laptop, we're talking 50 grand times 8 cores, $400,000 US to license my iPad. Holy mackerel. And Tejarob says, do people actually pay $7,000 a core? Yes, absolutely, totally, because it is really cool. It's good. Jedi Mind Gorilla, so does Enterprise handle a sort, but Standard does not? No, it has nothing to do with Enterprise versus Standard. It's just that as you grow, you generally need Enterprise. There are a lot of things that you need Enterprise for. For example, to handle as much memory as my desktop has, you need Enterprise Edition. Seems a little odd, but I digress. So the costs are one way to estimate and compare between these two. Another way to do it is to switch over and say, before we had set statistics IO on, and what that did was it gave us the number of logical reads over here in the messages tab. Let's turn something else on too. Let's also say statistics time on. What this will do is over in the Messages tab, it'll tell me how much CPU time SQL Server used in order to build these query results. So the top one, with no sorting involved, the top one finished in 45 milliseconds of CPU time. The bottom one took more than 3 times as much. Now, does anybody care about the difference between 45 milliseconds and 172 milliseconds? Well, as it turns out, yes. Because the more that you run queries like this, imagine queries like this on the home page of your website, if you have a query that burns 172 milliseconds, that means you can only run 5 or 6 of these a second, and you've maxed out 1 CPU core. Remember how a second ago I was talking about the difference between Standard and Enterprise Edition? Well, if you want to run 5 of these a second, there goes 1 CPU core. Enterprise Edition goes up to, Standard Edition goes up to 24 CPU cores. 24 CPU cores sounds like a lot, but if you can only run 5 queries per second per core, you're still only talking like 120 queries per second with all you'd be able to run. And companies like Stack Overflow need to run tens of thousands of queries per second. So trying to sort in the SQL Server side ends up being really expensive, especially when you learn about how SQL Server handles running larger queries. Because what I've done so far is I've only been selecting ID. Your users don't run queries like that. Your users do this, select star. So now let's think about how this is going to work. How is it going to work when we run select star? Sabi says, I'm starting to appreciate Postgres even more. I spend about 50% of my time in Postgres and 50% of my time in SQL Server. And there are things that when I come back to SQL Server, I'm so happy for, like the missing index recommendations. There's a lot of cool stuff that Postgres doesn't do that SQL Server does kind of just do for you. But for the money, it's really hard to beat Postgres, which is why we use it internally in our own company for the applications that we build. It's really cheap. So now let's run select star. So let's run select star, and now how do we execute this query? If I have 7,400 people or 7,400 pages that I got to go pull my data from, I'm going to grab my friends like Rudra from Plano, Texas. I'm going to grab all my friends. We're all going to go into the supply closet together, and we're still going to have to scan all of these 8K pages, and we're still going to have to write stuff down and sort it. This part doesn't change. Reading the 8K pages doesn't change much. There's a tiny change to it, but I'm not going to cover it inside this class. But this changes a lot. Because remember before, all we had to write down was ID and last access dates. Dennis Donuts, thank you. I'm glad you came in this morning and brought the donuts. I'm looking forward to, as soon as we take the next bio break, I'll have some of your donuts, please. You can just leave them on the counter and I'll go pick those up. I appreciate that. That's very kind of you. So now though, when I want to go do this select star, this is going to be really different. If I turn on my actual execution plans again and go look at this thing, let's go look at how the execution plan works. The shape looks the same. We still start with a microservice that scans the entire clustered index. But now when I hover my mouse over that microservice and I look what it outputted, we still read about 300,000 rows and we output about 150,000, but look at this hot mess down here now where we are putting all of this stuff. Chino says, I am 12 and dumb. Don't worry, in 10 years, you'll be 22 and dumb. And then at least you can buy alcohol. That was what worked for me. So here, now this is a microservice that dumps out 150,000 select stars. That arrow is now a much larger amount of data flowing into this sort. And then if I look at what the sort's doing, it's still just sorting by last access date, but it has to output all this stuff. Now let's talk for a second about, those of you who are developers are like, wait a minute, this is ridiculous. If I was going to do this, I would go send all my friends into the supply closet, and I would only have them write down ID and last access date, and I would have them do the sorting here. Then, after they're done sorting, I would send them back into the supply closet to get all of the information for every row. Well, that's a good idea, But imagine how many trips you would make back and forth to the supply closet. And you and your friends are not the only ones who want to work in the supply closet. There are other people who need to access that data too. And the other people want to do inserts, updates, and deletes. They want to be able to take locks. But if you wanted to hold locks on this stuff as you were working back and forth, you would be a very unpopular person very quickly. So what SQL Server does is just grab everything that it needs from the first time it runs the microservice, and then during the second one, this one is a hell of a lot more work, but that's your problem. How much more work is it? Let's go see. I'm going to take, Martin says go for snapshot isolation. Yeah, but trust me, you still wouldn't like the results of that one. So if I take these two queries back to back, one with select ID, and then one with select star. The first one, I'm only getting the ID. Second one, I'm getting select star. If I look at the difference in plans, they look absolutely identical. But start to hover your mouse over the first one. First one, remember, cost about 13 query bucks. The second one, buckle up. This is terrible. Now, this is why you'll often hear people say, especially angry database administrators, don't select star, only get the columns that you need. And they're right, because the more columns that you add to your query, especially in combination with an order by, the more the query sucks. But you want to keep things in perspective. The select star isn't the problem. The order by and the select star combined together are the problem. Because watch what happens if I just say select star and I don't have an order by on it at all. And I look at the cost of these two in comparison. The top query, all it has to do is go scan the clustered index. If I hover my mouse over the select star, it's only 6 query bucks. Whereas the bottom one is more than 100 times higher. It's the combination of select star and the order by that sucks. Botsko says, what about looking at data in edit mode in SSMS? Yeah, that's kind of bad too. You don't usually want to do that. So this is bad enough where SQL Server goes through and does this whole entire clustered index scan, reading all of the pages from the table, scribbling down hundreds of 100,000 last access dates, locations, all kinds of stuff. So it says 10x. Oh, thanks. Okay, yeah, gotcha. I was still thinking about my 100x difference in the query cost. SQL Server has this huge, spectacular amount of work to do where it's sorting all these little rows. Here's where this news really starts to suck. I'm going to run the same query several times in a row. I'm going to put in go 10 to make this query go run 10 times in a row. And while it runs, I'm going to go fire up Task Manager so that we can watch the performance on my CPUs while these run. So it's settled down to 0. Now let's go through and run it 10 times, execute, and watch the CPU go. If you were going to send your friends into the supply closet, if you knew you were going to do this query 10 times in a row, I bet you would say, okay, folks, let's go into the supply closet. Everybody go scan the table, sort all the rows, get back to me. Now, I know we're going to run this query a few times in a row, so just do me a favor, hold on to these for a minute. Because if I ask you for this data again in a second or two, I need you to be able to repeat those same results. Oh, that's not what happens. These get thrown away every time a query runs. SQL Server resorts, it scans the entire table, writes out all these rows, sorts out all these rows 10 times in a row. That's why my CPU went through the roof that whole time. It doesn't matter if you're the only one in the database. It doesn't matter if the query was just executed. It doesn't matter if that data's still in cache. It doesn't matter if it hasn't changed. It doesn't matter if the database is read-only. SQL Server still rebuilds the results every single time. Sammy says, does group by do the same thing? Yep. Joins, anything that you do in a query, SQL Server caches these SQL Server does not cache these. This is one of the reasons that Oracle costs $47,000 a core for Enterprise Edition. Oracle can do this. You can flip a switch in Oracle and you can cache your query results for periods of time so that if someone comes and runs the same query again, it can hand you the results without reinventing the wheel. But at $47,000 a core, it should do that. It should make you coffee and bring you breakfast and wash your car at that kind of money. Postgres doesn't do this either. So with SQL Server, how am I going to make this fast? How am I going to make it so this query runs very quickly over and over again? This is, and let's see here. Azure SQL has it in maybe soon on premises. Nope, Azure SQL DB does not cache query results either. Womp womp. And Nextdoor says, or just keep all your rows in RAM for more money. All these rows are in RAM. This table is very small. I'm not hitting the disk. I have the same problem, and Hannah has the same problem. Just because they're in RAM doesn't mean they're sorted. So Eamon says it shouldn't need me at all. I know, right? SQL Server should just manage itself. Although on the flip side, then we wouldn't have jobs. That would not be quite so good. Now, Jedi Mind Gorilla, you've asked a question a couple of times, and I'm not quite sure what you're asking. You say it seems to select star, then order by the date, but is it really sorting each item, but only displaying the sort of the date? It is writing down all the whole select star and moving these rows around, and yes, it's expensive as hell. Okay, so how are we going to make this fast? This sucks pretty bad, and we need a faster way to do this. We need it so that, he says, I think out loud. I apologize, I have it. We don't have to type it, man. You can just, say the stuff out loud. Jeez. So how are we going to make this thing so that it's fast and have it so that multiples of these can run at exactly the same time without doing so much work? That is where indexes can come in. Jedi Gorilla, yes, exactly. I told you you'd call me out. This is where indexes come in, and that will be what we get to after the bio break. So we've been going for about an hour now. What we're going to do, optimize for ad hoc. Nope, not even close. Same exact problem happens. Makes no difference whatsoever. I love that you would ask that, but no, that's not what that's for. So what we're going to do is we're going to take a 5-minute bio break. I'm going to go refuel, go get myself some more hot water and some coffee. And then when we come back, we're going to dig into non-clustered indexes. So, and Krunal says an index seek, great, yes, but you have to build the index. This is the part where it's your job, is you have to go build an index for SQL Server so that it'll do it for you. So we'll take a 5-minute bio break. It's 2 minutes after the hour. I'll be back at 7 minutes after the hour, and I'll see you back here then. So see you shortly. There we go. All right, so coming on back. Howdy, folks. Jedi Mind Gorilla says, cool view. This is probably the one thing that keeps me sane during the quarantines. So I've been telecommuting for like 15 years, longer than that, like 16, 17 years. And I'm very used to working from home. I'm very used to being cooped up. I'm totally okay with it. You know, when I first got started telecommuting, it was very tough dealing with being stuck inside. I would want to go out to eat, go out to lunches, dinner, whatever. But having a view is the one thing that keeps me sane these days, because at least it feels like I'm outside. We have floor-to-ceiling windows in our place, and we're in downtown San Diego, so there's always a view. There are always things going on that I can go off and look at. And it's funny, so I have two different glasses. You'll see me switch back and forth when I do stuff like live streaming. I have a different set of glasses for computers than I do for when I look outside or when I'm walking around the apartment. Jedi Mind Grill says, mine is a boat. Oh, I am jealous. That is awesome. I would totally love that. But although I don't know, you know, they always say that you don't really want a boat, you want a friend with a boat is how it usually works, so that they can pay all the money for that kind of thing. But it's just so nice to just look outside and feel like you're still a part of something. That's been absolutely fantastic. Because the apartment we were in before this, we were in an apartment in Chicago saving money, and the thing was like a dark tunnel. We didn't have any kind of view. I looked out on like an alley with a track. Jedi Mind Grill says, come to Texas, we'll take you offshore. I lived in Houston for several years during a couple different parts of my life. I think I've lived 7 or 8 years altogether. And my wife's family is still in Houston, and I thought for sure she'd want to go back, because it's so cheap. The cost of living is so cheap. It's you can get huge property. It's nice, I think, pretty much year round there. I like the heat. I don't mind it at all. But my wife can't stand it. She's like, my family's still there. As long as my family's there, I'm not so sure that I want to live there and be close to them. And I kind of get it. Because I kind of get it that why she wouldn't want to live near her family. I don't want to live near my family either. I've done that for years, and I'm like, no, it really, family's better if it's about 2 or 3 hours away at least, or a plane. And now, right now, it's a little tougher because if family falls ill, then it's a little bit harder. But all right, so back over to the training. So when last we met, we were doing, Sam says, hi, I'm an IBM developer. A company I'm working for is going to use Dynamics Nav, so I'm trying to learn more about SQL Server. Hey, so here's the deal. Don't judge SQL Server by Dynamics Nav. Dynamics is terrible. It does really terrible things to databases, just awful things to databases. Don't blame SQL Server for that. You're going to have a colorful experience with that. Amiga Live. Oh my God, I haven't heard of Amigas in years. Oh, that Amiga would actually be excellent. So what we were doing was, Christopher says, I'm a developer for 2 years from the UK, been put on paid leave. Ooh, wow, that's a mixed blessing, right? Can't wait to apply your performance videos. Very cool. So in here, when last we met, we were dealing with a really ugly select star, and even just a select ID will end up killing you. Even if I go back to just selecting ID and I go run this 10 times, I said SQL Server churns through CPU over and over again, sorting your results over and over again. And I said, if we're going to make this fast, we need some other way to do it. And that's where indexes come in. So I'm going to go create an index. I'm going to say create index last access date ID on DBO users, last access date. Thank you, Dave. I appreciate that. And ID. Woo. So, and when I create the index, the execution plan of the index isn't as much of a point, but let me show you where are my courses? My courses are at brentozar.com. So that's where. brentozar.com is where you can get all of my stuff. So if I say select what I'm going to do is I'm going to show you the contents of what's inside the index. I'm going to say select last access date ID from DBO Users, order by last access date ID. So what I'm doing here is I'm writing an index visualization query. We go into this in fundamentals of index tuning, how you can see the contents of an index. When you write a good index visualization query, what you should see is an index scan of just that index and nothing else. So here, I'm seeing a scan of the brand new index that I created. For those of you who printed out the pages, printed out the materials, these are the black pages of the index. Is this applicable for most databases? It's hit or miss. It's hit or miss. Some things are relevant, some things not so much. So in here, what I'm looking at is the black pages of the table. Now the black pages of the table, because they only have last access date and ID, I can cram way more users per page than I can with the clustered index. This copy of the table is way smaller because it has less data in it. And you can actually see the size comparisons if you want to with a tool called SPBlitzIndex. If I say SPBlitzIndex table name equals users. SPBlitzIndex is a totally open source script that we distribute in our first responder kit. It's available on GitHub. If you Google for SPBlitzIndex, there's all kinds of stuff out there about it. And the only thing that I'm concerned with in this result set is the first set of columns. The first set of columns says, here are the indexes on the table. So here's the white pages. The white pages of the table, aka the clustered index, have all 300,000 rows and they take up 58 megabytes worth of space because they have all the columns. However, down here, the non-clustered index, this only has last access date and ID, so this, even though it has all 300,000 rows, is way the hell smaller. Way the hell smaller, like 10 times smaller. So if you're going to scan something, it's going to be way faster to scan this than it is this. It's just that this isn't going to have all the columns inside of it. The other thing that you're going to notice is that I now literally have two copies of my table. Every time I do an insert, update, or delete, I got to change both of these. I got to keep both of them in sync. There's no concept of like asynchronous indexes yet. Hopefully there will be at some point in SQL Server. We have kind of hints of it in an undocumented feature. But there's no concept of disconnected indexes right now where I can keep my indexes up to date later. Jedi Mind Gorilla says that's an awesome use of the blitz that tells me a ton that I was curious about. Yes, this is one, that table name method is one I use constantly in order to show which indexes are being useful and which ones are not. So now when we go back to our query, SQL Server has a decision to make. Now, when I go to run this query, let me go put that up on the screen, just kind of organize my screen a little bit here to make it easier for y'all. Now, when I go to run this part of the query, SQL Server has a decision to make. Should it use this copy of the table or this copy of the table? Well, if you were going to send your friends into the supply closet, it would be pretty obvious what you would do. You'd be like, look, don't scan the entire table. I've got a copy that's organized by last access date right here. All you have to do is go run to the last access date copy and start reading the rows out. And that's exactly what SQL Server does. Now, I only have one microservice inside my execution plan. And again, I love these execution plan icons and the names. They tell you a whole lot about what SQL Server's doing. Now, SQL Server says on the non-clustered index, the index that we just created, I'm going to seek into it. SQL Server is going to open up to a specific page and start reading instead of a scan. Last time we were doing a scan, but now the data is organized in exactly the way that we want. And if I hover my mouse over this, it tells me, here's the thing I seeked into. The seek predicate says I'm able to jump directly to one specific last access date and start reading. And the hits keep coming. If you look further up, how many rows did I actually read? I read way less rows in order to find the rows that I need. So the index, now Peter, I'm going to address that one later. It's a great question, but I'm going to hit to it later and I'll explain why that is. So in here, SQL Server read less data. Instead of reading 300,000 rows, now it only reads 150,000 rows. Before, when we had the clustered index scan, SQL Server was reading about 7,000, 8,000 pages. Now we only read 335. This is the conventional wisdom that everybody kind of gets. Indexes help you read less data, but that's only half the story. Indexes help CPU time drop. Because the amount of time that this thing needs in order to execute, if I go look at the Messages tab, wha-pow, now my CPU is down to just 16 milliseconds. Before, when we were having to do all that sorting and all, we were talking about 170 milliseconds worth of CPU time. Now it's down to 16 milliseconds. That's frickin' nothing. This is the second benefit of indexes. Not only do they help you read less data, they also do less CPU work. Now in this case, this particular index is called a covering index because it perfectly covers the query that we're running. But as soon as I change the query, that will no longer be the case. For example, what happens if I say, also give me display name and age? Now we have a problem. Because now SQL Server can't use one index, one non-clustered index, in order to accomplish this goal. If you were going to go send your friends into the supply closet to go do this, you would give them one of two options. You could either say, go into the supply closet and scan the entire table. Just read all of the rows all together and then go sort them. Or you could go into the closet, go seek to the specific rows that you want by last access date, write them down somewhere, and then go do a bunch of key lookups over here, over to this table, in order to get the rows that you want. Let's see which one SQL Server did in this case. Let's turn on actual execution plans and run it. And here's what it did. Remember, if we read from right to left, the first thing that SQL Server decided to do was a clustered index scan. SQL Server didn't use the index. SQL Server ignored our index. More on why here in a minute. SQL Server scanned the whole entire table. It outputted all those IDs, last access dates. Then in the next step, it writes down all that stuff and sorts it. Meanwhile, Clippy's up here going, hey buddy, you know what would really help? If you had another copy of the table. I love making copies of tables. Anytime you need me, I'll be in the supply closet making copies. He doesn't care at all about how much slower your inserts, updates, and deletes get. All Clippy cares about is how fast he can make queries run. He's not even really good at that. But he has a point. The query would be faster if we had that index. How much faster? That's an item for debate. So why didn't SQL Server use the index? In order to figure it out, what we're going to do is we're going to change this last access date to say 2020 and then run the query again. If I go look at the execution plan, now it looks totally different. Now SQL Server said, oh, I know there aren't going to be a lot of rows that match. I estimate that one row is going to match. SQL Server, even if he's pretty confident there's no data, he still thinks you're looking for rows that exist. So he says, I estimate there's only going to be one row, so I'm going to go send somebody into the supply closet to go look up in the index. I'll have them go write down the ID, and then I'll have them go do a key lookup. Because here's the thing, we got to do a key lookup against the clustered index because our non-clustered index doesn't have display name and age. We got to go get display name and age from the clustered index, which does have all of our columns. Doing this key lookup adds additional reads. The more rows that we find in here, the more reads we would have to do in here. In order to prove it, what I'm going to do is go back to the original date. I'm going to go back to 2014, and then I'm going to run the query two ways. I'm going to run it letting SQL Server choose what it wants to do, and then I'm going to give it a hint. You know, kind of like how when my wife gives me a hint, it's not really a hint, it's more of a requirement. I'm going to say index equals, and I'm going to tell SQL Server which index to use. So then I'll run those two queries back to back. The top one, SQL Server gets to choose. In the bottom one, I'm telling SQL Server. So in the top one, we did a clustered index scan. The bottom one, we did the non-clustered index seek plus a key lookup. In the top one, I'm going to set off stats time for just a second. Set statistics time off. Turn that off, and then go run these two queries again just to clean up my messages tab a little. In the top one, we read about 7,800 pages. We scanned the whole table. In the bottom one, whoa, that's more pages than there are in the table. We read 500,000 8K pages. How does that even happen? Well, here's how it happens. The first thing that we start with, when we run that bottom query, if I run just the one that does the index seek plus a key lookup, if I run the bottom query, the first thing that SQL Server does is he does an index seek in here, and he pulls out 149,000 rows. And then for every row that it finds, over here, it actually does this multiple times. I really wish that execution plans were three-dimensional. I wish they popped off the page in terms of the number of times that they were executed, because when we look at that execution plan, it's very tempting to just think of it as one key lookup that was done one time, but that's not what it is at all. It was done 150,000 times, and each time that you do it, it's multiple logical reads. That's where all these reads are coming from. You're sending your friends back into the supply closet to look people up one row at a time. So SQL Server made a smart decision here, and it made this decision all based on that number or that date. If I change it to something that doesn't produce a lot of rows, then SQL Server uses the index. If I change it to something that produces a lot of rows, it doesn't use the index. SQL Server has to figure this out before your query even starts. You're not allowed to send your friends into the closet. Oh, Mr. P. Shaw says, how do you get time to show in the execution plan? It's with newer versions of Management Studio. So if you get to newer versions of Management Studio and SQL Server, I want to say that this has been out for a year or two, maybe, ballpark. Don't quote me on the exact time. It's been maybe a year or so. And also, it'll only show on the actual plans too, not the estimated plans. Saturday night SQL Server, that's pretty much how all of my weekends go. Well, as a side note, so what is it that I do? Why am I here with y'all? Why is it that I get up on Saturday mornings and go do this kinds of thing? So the reason why I do this is that my wife sleeps in on Saturday and Sunday mornings. This is her weekend, so she'll go off and sleep in. I don't do client work on the weekends unless somebody hires me. They can hire me for weekend emergency rates. Mr. P. Shaw says, I thought I was on the latest version. It's okay. It's all right if you're misled from time to time. It's all right. So she sleeps in. And she even just texted me while I was streaming, and she's like, hey, I hear that you're up and around. You can go ahead and go out and get breakfast on your own whenever you wake up. So at 8 a.m., I am out of here. Well, I might push it to 8:15 because I'm going to place my order online and then go down there and they'll have it ready for me, but it's be pretty close. All right, so back over here on the, one is the loneliest number. One is the loneliest. So how does SQL Server do this? SQL Server has to figure out, before he sends his friends over into the supply closet, SQL Server has to figure out how many rows are going to come back for your query, and he's not allowed to look in the supply closet. He can't go take a peek. So how does he do it? The way that he does it is every time that you create an index, SQL Server creates statistics with exactly the same name. So you saw that I have a clustered index, and I also have this new index that we created on last access date and ID. Yeah, it's very bad magic. This is actually pretty cool magic. I kind of like this. So here, SQL Server creates statistics automatically with exactly the same name. So you see there's this statistic down here called last access date and ID. So what's a statistic? A statistic is one 8K page worth of metadata to describe the contents of the object. So if we create an index, SQL Server creates one 8K page with data about what's in the supply closet. It's fair for SQL Server to look at this, but it's not allowed to go into the supply closet to actually examine the object. So what's on this? Now, seeing the contents of statistics is not something that I do every day. I don't want y'all to think that this is a core part of my troubleshooting stuff. Well, Lasamat, you can go start watching the session again from the beginning to catch it. I won't go revisit that one at this point. So I'm going to say dbcc show statistics DBO users and last access date ID. All right. Now, if I come back in here, I don't want you to think that I run this all the time. I freaking never run this. The only time that I run this is during training sessions so that I can show you how SQL Server thinks. I usually don't need to look at stats on a column to understand what's going to be in there, and neither will you, the more familiar that you become with SQL Server. What this is it's one 8K page worth of metadata, so there's not a lot in there. Let's see how it works. The first set says, here's the stats name, here's the object that it's on last access date ID index. The last time we updated is May the 16th. At that time, there were 300,000 rows in the table, in the object, and SQL Server sampled all 300,000 rows. The larger, no, Martin, you're not right there. That's actually not true, so hold that thought. So y'all are going into all kinds of other questions. So let's hold on and focus on this for a minute, because this part is going to be kind of tricky as you go through and learn this. And I know a lot of you think that you know things inside here. Hold on, you don't want to look stupid. Just as a side note, try to avoid answering things during other people's webcasts or sessions, because you don't want to look dumb when it turns out 30 seconds later that your answer was wrong. The thing that you want to do instead is say a friend of mine said, or I read somewhere that. That way, if you're completely and hellaciously wrong, you don't look stupid, just your friend does. And then that way, when I tell you how wrong your friend is, you can be like, oh yeah, that guy's pretty bad. He does drink at work a lot. Also, he's me. But so just as a sign, or use Jedi mind tricks to make him miss the comment. That works as well. Yeah, type real fast, make lots of comments, and then it hopefully blows past. So this is one 8K page worth of metadata. This object had 300,000 rows in it, but the longer, Richie says, my boss says, your boss, actually correct. So in here, it has 300,000 rows. That's a relatively small object, but the larger that your objects become, the more SQL Server starts to resort to sampling. It'll just pick random rows or random pages out of a table. It has a strategy for it, but it'll sample just like a political pollster does. You know how political pollsters, when they want to find out how everyone's going to vote in an election, they don't have time to call everyone on the phone and ask them all how they're going to do. They just sample. So here, SQL Server sampled all 300,000 rows, so it has a really good picture. Then, this statistic is on two columns, last access date and ID. But here is the statistic. Here's the part that's really interesting. SQL Server has up to 201 buckets. This is a hard-coded number because this is all SQL Server expects to be able to fit on one 8K page. Other databases have different kinds of options, but SQL Server is going to give you 201 buckets. And then the buckets describe the contents of this index. For example, in the first bucket, for last access date equals August the 1st of 2008, there is exactly one user with that last access date. which tells you, for example, that's when Jeff Atwood and friends started developing Stack Overflow. That was the first date inside that database. Oh, Dimitru, thank you. I appreciate that. Oh, very cool. Very nice. Very cool. Oh, and I think I have sounds for that, and for some reason they're not on loud enough. Let me go fix that. Let's go turn that way up so that the next time we get sound effects when people subscribe as well. So in here, there's only one row with a last access date equal to that. Now, in the next bucket feels a little different. In the time of last access dates between August the 1st to November of 27th of the same year, there are 1,200 rows in that bucket. One row is exactly equal to this. And then out of those other 1,222 rows, they are all distinct last access dates. Well, of course they are, because it's a website and not everyone logs in at the same time. People are going to log in at wildly different times, so all of our data is going to be distinct. This is exactly how SQL Server guesses how many rows. Brendo's R is brilliant. I'll give you 15 seconds to stop that flattery. So this is how SQL Server projects how many rows are going to match whatever your predicate is. So a second ago, when I ran the query and I said, hey, show me all the users where last access date is greater than 2020 July the 1st, SQL Server opened up its statistics, scrolled down. Fest3 says this guy is smart, I guess. Yeah, that's it. Yeah, it's fair. SQL Server goes down through these statistics, and the most recent date that it has is September the 9th. He goes, well, I'm not really sure. I guess I'm going to estimate one row. SQL Server always assumes that there's going to be data that matches yours. Sammy says, do the stats update with index updates? That's beyond the scope of what I'm going to cover in this session. I do talk about it in fundamentals of index tuning, though, and I'll give you a coupon for that at the end of the session so that you can get it for less than $5 and then go continue on with your learning journey. So if I change these dates, I'm going to take this date right here. I'm going to copy this out, and I'm going to say back over on my query, where the last access date is greater than this. And we'll say greater than or equal to this. Oops, let's go through and run it like that. Now, how many rows does SQL Server think is going to come back? One, which makes sense, because if I go back and I look at my statistics histogram, that is the high key. That's as high as it went. Let's go one earlier. Let's go a little bit earlier, and let's see what his estimates look like. Paste, and go try it again, and look at what we have here. SQL Server, I get so excited with this stuff. It's just cool how it works. So SQL Server says, I believe there are going to be about 748 rows that come back from that. Where did he get the number from? Back over on statistics. Look at what we have here. So there are 746 rows in this bucket itself, plus SQL Server thinks there's probably one beyond, just assumes that there's always going to be an extra row, and then it also knows on this exact date, this row itself is included as well. Oh, this is so neat. This is exactly how SQL Server is figuring out these estimates, and you can use them too. So this is how, when SQL Server said, back when we asked for everybody higher than July the 1st, SQL Server said, okay, what I'm going to do is I'm going to go open up my statistics. I'm going to look for July the 1st of what date did you use? I'm real forgetful. July the 1st of 2014. So he's going to go, all right, well, I don't really have an exact bucket for July the 2014. I know some of the rows in this bucket are going to match, and then all of the other rows. So SQL Server goes and adds up all these numbers, scrolling down through here, and this is where it comes up with his estimate. This is how he figured out, yeah, you're welcome. This is how he figured out how many rows were going to match when we did this query. And that's why he said, oh my God, if I have to execute that query, it doesn't make sense to use the index because I believe about 148,000 rows are going to come back. This concept is called the tipping point, where it makes more sense for SQL Server to use an index versus where it makes more sense to just scan an object like a table. And here you can start to see it as you try different dates for the same query, where SQL Server will end up making different choices depending on how many rows it thinks are going to come back and how the indexes are going to work. Well, meanwhile, we got Clippy. Hey, buddy. Oh, you know what would be amazing? Sergio, that's a great question. I'm going to leave that off for a separate session, though. I have a course just on statistics. So if you go to my YouTube channel and look at statistics, there's a whole course just on it. Martin says Century 1 even has tipping point info in the newest release of the great free tool Plan Explorer. Yes, but it's wrong. I posted a blog post last week about how that feature is actually incorrect. And they updated their blog post to talk about when it's wrong. But I love their idea. It's a great idea. It's just wrong. Okay. So here's Clippy. Oh my God, buddy, you know what would be amazing? Oh, I really need an index. And he's right. Yeah, this query would be a little bit faster if we had an index to completely cover this. Paresh says, can we parameterize this for a better plan? You can parameterize it and get a worse plan. And I talk about that in my class, Fundamentals of Query Tuning. So I'm going to make a bigger index. I'm going to make an index that matches what Clippy wants to do. But before I do that, I'm going to show you how to kind of see it in your own execution plans. In here, I ran the query that used the index. I looked for a fairly recent date, and it does an index seek plus a key lookup. When you see key lookups, if you need to get rid of them for some reason, they're not always bad. In this case, they're actually fine. This query runs so insanely fast, no one would complain. But if you had a key lookup and you wanted to get rid of it, you could, if you're lucky, get a hint from Clippy, but you don't have to. The other thing you can do is you can just hover your mouse over the key lookup and you get down here the object or the output list. SQL Server says, well, I had to go do this key lookup because these two columns down here, display name and age, they weren't on the non-clustered index. If you could just add this to the non-clustered index, I can make that key lookup go away. So let's do it. I'm going to go create another index. And Clippy says, just include these columns. I'm going to put them in the key. And I'm not going to go into why here, but I go into why in the written version of this class. So if I say display name and age, and then I'm going to say display name and age up here, I'm going to go create a wider index. Now, those of you who are following along with the printed handouts, this is the gray piece of paper in your handouts. Those of you who didn't print it to follow along can kind of get an idea of what it is when I hold it up to the screen. You can see that this index has last access date and ID, but it also has display name and age. So I can't fit as many users per 8K page on this one. The size of this index is larger, is physically larger. If you include columns or you put them in the key, in both cases, they are on the 8K page. So just to show you, Frozen Swede, remember what you're supposed to say. A friend of mine said, right? Oh, yeah.
Right
okay.
on.
There we go. So here, I'm going to make these indexes which just include. Now, in this case, Frozen Swede is correct, but yes. So let's go create an index that just includes those two columns. And then let's go look at our friend SP Blitz index again. SP Blitz index, table name equals users. So in here now, I have these indexes up on the table. I've got the black pages, the ones on just last access date and ID. Thank you, Yippee Hi. Very cool. Appreciate that. And two, for those of you who have Amazon Prime, you can use Twitch Prime. It doesn't cost you anything by subscribing to channels with Twitch Prime. It gives them a kickback too, so it incentivizes them to keep speaking. And I don't say that just to get me to keep streaming. I'm going to say, if you just lock me in a door or lock me in a room somewhere, I'm just probably going to start streaming things live, not in an attempt to get out, just because I like streaming. But if you have other streamers that you like to follow, by all means, encourage them, follow them, subscribe to them, so that SQL Server streaming itself is just kind of getting started right now. There are only a few of us who are doing it, so it just encourages more people to go do it. So in here, I got my 4 indexes. I got the black index on last access date and ID. Then I got these other 2 indexes with the UPI says, I hate to be the EU guy without the chance to get your training sessions. I'm working on that. It's just really hard. Your country doesn't make it easy, and they make it really expensive if I screw it up. Or it's not country. What do they actually call the EU? Some cat says, will this stream remain accessible later this week? Yeah, it'll be, Twitch lets me keep it up for 60 days, and then it'll be on YouTube forever, Facebook for forever. I think Mixer is forever too. I'm not sure on that one as well. So look at the sizes on these though. It doesn't matter whether the indexes are in the key or where the key columns are in the index includes. Shakar, just like a typical YouTube commenter, you say, what is something and how do I do it? That's what Google is for. It's Google. It's called an engine that helps you with your searches. It's kind of a... Yes. I know I do a lot of things for you for free. I love doing things for you for free, but searching the web for you, it's where I draw the line. That's where you're going to get up off your lazy bum. You're going to go do it yourself. Woo! So now in here, these 2 indexes at the bottom that are on last access date and ID, and then they have Grumpy Game Dev. You can see why Grumpy Game Dev subscribed to some comments like that. He's like, I got to follow this guy. He's kind of dumb. Sabi says, dumb questions mean ASMR. That means LMGTFY. That's what that means. And I'll put it out there in terms of LGT. Let me Google that for you. There you go. So in here, those 2 indexes that I have highlighted, it doesn't matter whether the columns are in the keys or the includes. They take up a whole ton of space. So I don't want you getting hung up on thinking which one of those 2 is better, putting them in the includes or putting them in the key. For mine, I'm just going to put all 4. I put all 4 of them in the key like this. And the reason why I did that will become more obvious later here in a minute. Display name, age. Oh, there's no commas inside there. Whoop-de-doo. Zero Cool LP says, I love how you do that. And yes. Very smart. I have taught you something already in the session. Zero Cool LP says, a friend of mine saw a video, Penal Dave at PASS, said that one index can affect the performance of other queries. He's right. He's totally right. And I love his demo for that. It's really cool how that demo works. Okay. So I've created this index. And what this index lets me do is that now when I want to run this query, and I'm going to run it at first with the small date range. I'm going to run it with the small date range, which before was doing an index seek plus a key lookup. But now that I have my fancy pants index, woo! Now that I have my fancy pants index that covers the whole thing, I just seek directly into there and I read the rows out. Oh! So that's fantastic, but wait, there's more. Now, when I run it for the big data range, when I go all the way back to 2014 and I execute that, if I don't type E, I hit Control E. When I execute that, I also get an index seek plus a key lookup. It doesn't even matter if I take the where clause out. If I take the where clause out of the query altogether, SQL Server still uses that index because it's a narrowest copy of the table that achieves our objectives. This is a covering index that works absolutely beautiful for this query. But the order of columns is so incredibly important. YGDev says, nice and encouraging teacher. Thank you, thank you. My whole goal with this whole streaming and everything else like that is to make things suck less than it did for me when I was starting up. Because man, when I started up, learning sucked. When I was your age, thank you, Kevin BDA. I appreciate it. That's very cool. So when I started up, when I was your age, I had to go through like stone tablets, something that they called books online, which wasn't even online. It was offline. It was kind of like directly into your computer, and there was no internet, whatever. Manny says, so there's no use of the include clause? There is, but I'll talk about that in my class, Fundamentals of Index Tuning, that you'll get a coupon for here in about 15 minutes when I get bored of you and I go off and go get my coffee downstairs. CloudDB says, what is the difference between your index from the SQL Server missing index? Mine has all 4 in the key. So now let's go talk about why that matters. So in here, I've created this index right here. I've said I want an index on last access date, ID, display name, and age. Now I'm going to write a couple of queries. And in fact, I'm going to drop all my other indexes. I have a stored procedure called drop indexes, which goes through and drops all my non-clustered indexes. It's a great thing to do right before you leave a job, just on your way out the door to run that thing. And of course, I'm kidding. So now I have that index and nothing else. SQL Server loves using that index. It's more than happy using that index for that query. What about for other queries? Let's try writing another one. So let's say, here's my index up at the top. Let's say select ID, or we'll say all 4 of them, last access date, ID, display name, age, from DBO users, where display name equals Brent Ozar. And let's go run it. Will SQL Server use this index? Will SQL Server use the index that's up there in order to accomplish this query? I'll let y'all tell me over in chat, Twitch, whatever chat messages you want. I want to hear, will this query, when I go look at the execution plan, will this query have that index in the execution plan? Yes or no? Let's go see. 10 seconds to go answer it.
8, 7, 6, 5, 4, 3, 2, 1.
Oh, that's not enough answers. Let's go see, because there are like, what are there now? 130 of y'all just in Twitch alone. So I'm going to make you answer it before I go on. I want to see at least like 20, 30 answers before I answer it. So
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
All right, so let's go see. So if I execute that query and I go look at the execution plan, so it did, but what a lot of you nailed is that it's not a seek, it's a scan. SQL Server scanned the whole entire thing, and you can see it if you hover your mouse over it. If I hover my mouse over it, I can see the number of rows read. How many rows did SQL Server actually read in order to produce these results? So SQL Server read all the rows in here. And you might be thinking, well, wait a minute, Brent. What if it's going to read all the rows, why not just do a clustered index scan? Da, 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 da. Video. Thank you for pizza. I appreciate that. Very cool. And Mr. P. Shaw, or Mark Shaw, if I remember right, Mark Shaw says we scanned it because it's smaller, and that's exactly right. Let's go back and look at the contents of our 2 indexes. The top one is the clustered index, aka the white pages of the table. The white pages of the table have all 299,000 rows. Mike, that's what it is, Mike Shaw, thank you. 299,000 rows, but it's 58 megabytes in size. The index with last access date, display name, and all that, it's smaller. It only has 13 megabytes. So if you're going to send all your friends to the supply closet to go scan pages, do you want them scanning the big stack or the short stack? Now I want pancakes. You'd want them to scan the short stack. You want them to scan as little data as possible in order to get the job done. That's exactly what SQL Server does. He scans the narrowest copy of the table, but it ain't a seek. We are reading the whole frickin' thing, and you can see it when you see number of rows read, 300,000. The order of columns in an index is super important. Whatever you have in your query in things like where and order by really need to be one of the first columns in the index, and Tejareb nails it. Only the first key column is seekable. As long as you're specifying that first column, you can seek directly in. Jedi Mind Gorilla says, so if you had the where as the last access date, will it seek? Yes, sort of. Now, watch this. Let's say where last access date greater than 1800-0101 and display name equals Brent Ozar. Paul, good, glad to hear it. You're welcome. So now when I run this query, this is kind of messed up. SQL Server. Now remember, I always use a guy's voice for SQL Server because he's dumb and stubborn and he refuses to ask for directions. He's all, trust me, I got this, when he doesn't usually got this at all. Here, SQL Server says, no, trust me, I got this. I got this index right here and I can seek on it. Okay, SQL Server, what are you going to seek to? I'm going to seek to the days of the covered wagons. I'm going to seek to 1800, and then I'll start reading. Well, wait, what? How many rows are you going to read, SQL Server? All of them. I'm going to read 299,000. Wait, what? Seek, the word seek, doesn't mean it's lightweight, doesn't mean it's fast. Seek literally only means I'm going to jump to a point and start reading. You could jump to the first row of the table. You could read the whole thing. That's exactly what we're doing here. That's what Tejareb says. That's what I would call a scan. I agree with you. This is what I would call a scan, but that's not what SQL Server calls it. SQL Server calls this a seek because it jumped to a specific value. What I want you to get here is just because you see an index seek on a query plan doesn't mean it's a good index, doesn't mean that it was fast. You could be reading the whole entire table. Conversely, just because you see scan doesn't mean it's bad. Watch this. If I say go select top 100 star from DBO users and I don't put an execute or don't put a where clause on there, Martin Guth, you and I are thinking absolutely on the same page there. If I look at this, I say, hey, SQL Server, go get me the first 100 rows, and I don't care which 100 you give me. SQL Server just only reads 10 or 100 rows. He jumps right to the beginning of the table, reads a few pages, and he's out of here. For this, a clustered index scan is perfect. I don't think that you could do any better than that for this particular query. I don't want you thinking that index seeks are good and index scans are bad. They're just different tools that make sense for different times. What I would probably say is, what kind of moron would put last access date greater than 1800-0101 in their query? It's just idiotic. If you're going to be looking for something unique, like display name equals Brent Ozar, you know what you really need? Is you need an index on whatever that column is. If I go look back at the execution plan, Clippy doesn't have any ideas. Clippy's like, I got no suggestions. If you need me, I'll be over here reading the whole table every time it runs, going all the way back to the days of covered wagons. Love you, buddy. You paid a lot of dollars for my CPU cores. I figure you should get your money's worth out of there. This sucks. You could do way better if you had 5 minutes worth of time. If you had 5 minutes worth of time, you would look at the contents of this where clause and say, hey, you know what? Order really matters. I don't want my index for this query to start with last access date because it means I'm seeking back to the days of covered wagons. What I need instead is I need an index on a different column order. I might need an index display name on DBO users display name, and I'm not even going to put anything else in the index, just display name and nothing else. Let's go create the index just on display name, and let's see if SQL Server will use it now for this query. And of course, he does. SQL Server knows because there are statistics on the display name index. SQL Server knows that there are only going to be a limited number of rows that match. So now he's able to seek just directly into Brent Ozar. And then, sure, he does a key lookup in order to get the extra columns that we didn't have on the index. But who cares? One key lookup is actually great for this. This is phenomenal. Now, what we saw before was just an index seek in the plan and nothing else, and that sucked. SQL Server read the whole query, read the whole table. Here, we see an index seek plus a key lookup. This is actually way faster and less logical reads. Tehareb says, can SQL Server or any other RDBMS do a key lookup to another index? Yes. So SQL Server can use two different indexes to accomplish the same query. What I'm going to do is I'm going to drop both my indexes, and then I'm going to say create index display name on DBO users display name. And then I'm going to create an index location on DBO users location. So now I've got two indexes there. Then I'm going to write a query to find the stuff that I need. I'm going to say select star from DBO users where display name like Brent and location like California. Well, we'll say San Diego. San Diego. So let's see what SQL Server decides to do here. It could use either index or both. Let's go execute and see what he decided to do. And it's phenomenal. SQL Server decided, based on the selectivity, that it should find all the Brents, it should find all the people in San Diego, and then see where that overlaps. And he makes different decisions based on what you're passing in. If something on there is really unique and selective, like, for example, if I say Brent Ozar and San Diego, CA, USA, we might just use one index. SQL Server might use the statistics and say, you know what, that display name is really unique. I don't have to bother going across different indexes. So, Vinomiz says, can someone point me to a good query plan visualizer? The SQL Server Studio one is only worth when exported in XML. A lot of people like Sentry One Plan Explorer. So Sentry One Plan Explorer, it's totally free. You don't see me using that during my sessions just because I try to stick to the native tools as much as possible to meet everybody where they're at. But Sentry One Plan Explorer is pretty cool. If I had a full-time DBA job again, if I had to put on a suit and go to a real office, probably throw myself out of a window. But if I had to go back and do a real job again, I would probably do. I used to be a database administrator, and I know it's hard to believe, but a developer. Peter says, how do the estimated plans look like for these queries? Well, this is the point where we're at the end of the class, and I will point out that you are welcome to do all of this stuff. Everything that I do, I make totally open source. So for these databases, you can go to brentozar.com, go query stack. So if you go to brentozar.com/go/query stack, you can go download the Stack Overflow databases and you can try these experiments yourself. I'm running on the very smallest version of Stack Overflow's databases, the one that's just 10 gigs in size here, to make it as easy as possible for y'all to follow along with these demos. So now we are at the end of today's training. So we are coming up on 8 o'clock San Diego time. It is time for me to go downstairs and go get a nice pour-over coffee and a salmon bagel. So I want you to be able to keep learning. So for you to keep learning, I am going to give you a coupon where you can get my next class. So I'm going to go put this in over there in the chat so that you can get to it. And the coupon code equals wash them hands. We'll put that in over in chat as well. So if you go get that, that'll get you my Fundamentals of Index Tuning recorded class. You can go hop into that and start watching. It's built atop the Stack Overflow database as well, so that you can then go in, and it's only $5 after the coupon, so everybody can afford it. And then that way you can jump in and go right on learning about things like how do you choose which columns go first in an index? How do you write visualization queries? How do you know when you're getting a good seek or a bad scan or whatever? So there you go. It's like 95% off. It's usually $100. You get it for $5. It is good for today only. So it's something that I give back to folks who are watching the stream so that just that you can keep learning. And I hope y'all stay safe and healthy and enjoy your weekends. So go have fun and wash your hands, because heaven forbid, when I see y'all, I want to be able to shake your hands and all that. Botsko says, how long will this be free in our purchases? It's a 1-year subscription, so you get it for 1 year. It's not totally free, it's just $5. So, or like it's under $5. CloudDB says, what's the code? The code was up in chat, but it's wash them hands. So I'll put it up there again in chat so that you can see it. Wash them hands. And hopefully y'all have fun, have a good weekend, and I certainly will. I will see y'all later. Adios.